Hello and welcome to Multiframe Webinar 2, Video 3 on working with properties. We've set the properties of our joints. Now let's move on to our members. And the first property we're going to look at is member releases. A member release is when we release the moments at the ends of the member, or in other words, we create a pin joint at the end of the member rather than the normal rigid joint from that member to the node it's connected to. The only thing that's a little bit unusual in Multiframe is that the default behavior when we choose a pin at one end or the other or at both ends of a member is that Multiframe does not release the torsional or TX, local TX degree of freedom. And the reason for that is that it often creates a rigid body mode of instability where the member is free to spin about its longitudinal axis. And in most cases that torsional strength is not really relevant to the overall structural analysis. However, you should be aware that if your problem is particularly torsion dependent, then you should manually release that torsional moment. Also, at the bottom of the member releases dialog, remember there is an axial release there. It's not just the moments you can release, you can also release the axial PX dash, and that's for the situation where the member is supported but it's free to move in the axial direction, such as the propped end of a beam or bridge or something like that. So let's look how this works in Multiframe. So here we have a number of rafters in our model, and we can set the properties of those rafters. So we can set it to be rigid or we can set it to be pinned. And if we take a look at the member releases dialog box, we can see that by choosing the pin icon, we release our major and minor bending. If we wanted to explicitly release the torsion, we would select that option there. So member releases are pretty straightforward, and of course the bending moments will be 0 at the end of those members. Let's now take a look at a slightly more advanced but similar property, which is the option to define a member end spring. With a member release, our member is either pinned or it's rigid. The end spring provides the option for partial fixity using the end spring at the end of the member. It applies to all of the 6 degrees of freedom, not just the moments that we saw with the releases. So that means the 3 moments and the 3 forces at the ends of the member can all have their stiffness defined. And this is done by using an independent object between the member end and the node that the member is attached to. So as we see in this diagram at the bottom, we can have an end spring at one or both ends of the member. It's infinitely short and it allows us to define that stiffness. That stiffness can in fact be set to 0 if we want to, and if we did that, that would be equivalent to releasing the moments. But that's not really the preferred way to do it, and I wouldn't recommend that you do that. So the end springs let us do a fine partial fixity. Let's see the different ways that we can do that. The first is we can define the stiffness by direct spring stiffness, and that just means we define the stiffness of that spring directly in terms of its stiffness in kilonewtons or in kilonewton meters. A second option is to define the rigidity of the spring, and that's done using a formula which is a constant times the bending stiffness, the 4EI over L of the member. So when that constant is 0, that constant R, then obviously our member has its moments released, and so that's a pin member. And when R is infinity, our stiffness of our spring is infinite, and so that's equivalent to a rigid connection. Notice, however, in the formula there's an L in the formula, and that's the length of the member. So we have 2 variants here. We have one for the member itself, but if that member has been subdivided and then grouped together as part of a design member, the design member rigidity option lets us use the length of the design member for the stiffness rather than the length of the member. The second option, or at least the third option, the second rigidity option, the third stiffness option, is member fixity. And this, you can see, is a nonlinear formulation. With the R factor, it's a linear formulation, it's a linear proportion of stiffness. But with the member fixity option, it's a nonlinear relationship between the stiffness of the spring and the bending stiffness of the member. And again, because of the L value, we have the option of using the member length or the design member length. But because of this formulation, the n over 1 minus n factor You can see that when n is 0, we get a pinned release because the stiffness goes to 0. But to get an infinitely stiff or rigid end to the member, then we just need to set n equal to 1. It gives us a 0 on the bottom, and so a rigid member is n equals 1. So if we want to see the relationship between this factor n, non-dimensional factor n, and the resulting stiffness, we just go over to Excel. We can see that if we chart the value of n between 0 and 1, then we can see the proportion of stiffness that will get transferred, and this chart here shows us that relationship. So it's quite nonlinear. However, remember that the relationship between moment and member stiffness is also a nonlinear one. So if you actually were to plot a similar graph with the variation of moment at the ends of the member with this variation of stiffness, you'd find that it's slightly nonlinear, but only slightly. So this is actually quite an effective way to define the proportion of stiffness that carries over across the spring. So let's go over to Multiframe and see how this is done. So we'll select our rafters and we'll choose the member end spring command. Now what we can do is we can choose to release it at both ends of the member for major bending, minor bending, and so on. And then from the drop-down menu, we can choose those different options that I've just described. So if we choose the spring stiffness option, then we directly specify the stiffness for bending. It's in kilonewton meters per radian. If we're using the rigidity option, then we define our R factor, which is between 0 and infinity. But the one I really recommend is the fixity factor. If we use the fixity factor, it's a little easier to understand. This non-dimensional constant n is in the ratio of 0 to 1. So broadly speaking, if n is set to 0.5, we're going to get of the order of 50 to 60% of our stiffness in the member end spring relative to the stiffness of the member. So if I enter in those values, we can see how we'll get a partial stiffness there, and we'll see the icon for the springs in our frame. If we look now at a frame where we have one beam set to rigid, a second beam set to have member end springs with 50% stiffness, and a member with releases at both ends, and we apply a distributed load to each of those members, then we'll see in our bending moment results the amount of end force that we get, or end moment we get at each of those members for the rigid situation, the partial fixity, and the pinned ends due to the member releases. That completes our summary of member releases and end springs. Thank you for watching.